I've been going through and trying to try out each of the different opcode instructions for the PIC18, and today's opcode I'll be having a go at is CPFSEQ. This is under the byte-oriented file register operations, and CPFSEQ is compare a file with the WREG and skip if equal. I'm just trying to think of a way to pronounce this. Sure, I can call it CPFSEQ. That's a mouthful. So I'm thinking of calling this COMF skip equal. This is the code that I developed. The main thing here is trying out COMF skip if equal, but wanting to be creative, I thought, let's make this do something interesting I haven't tried before. So I thought I would take a blink, an LED program, and modify that a little bit. So although there's a lot of code here, it's nothing unfamiliar if perhaps you've watched my previous videos. In fact, I took the code from part 13 of my PIC18F4525 series, which blinks an LED, and I just borrowed the code that I already wrote. But in this case, I'm not going to blink a single bit or a single LED. I'm going to toggle, or complement is the better word, complement port D, which port D is the output that I designated up here. And I set port D at the beginning of this loop to equal 10 10 10 10. When it complements that through this delay routine, it'll make it opposite 0 1 0 1, etc. This isn't the point of my video. This blink program with a twist, which complements file output port, port D, SFR port. But it's just to make the video interesting. The real thing I'm trying to achieve here is this CPFSEQ, compare file, skip if equal. So I won't go into explaining the initialization I've done with my chip. Previous videos have done that. This is just here to get the chip working, designate port D as an output and port C as an input. Trice B is here from a previous. These equates up here are just to make this delay routine work. So on my breadboard setup, which I will show in a minute, I have a single push button on RC0, and when you press that, it'll change the value in the byte of information contained in SFR port C. So I thought I can work with that, because if I simply push RC0, it'll change the value in port C from all zeros to mostly zeros, and the least significant bit in port C will be 1. So if initially I move a literal value into the working register, that literal value being all zeros and 1, then if I compare the value that's now in the working register to port C, which I'm really just toggling with my finger, RC0 on and off, then I can compare this value with the value that I can manually control on port C as an input. So I will read through this piece of code here. I'm calling this main loop main. I'm moving a literal value into the working register, that being decimal 1 and binary 1 and hexadecimal 1, all the same thing, and it makes the least significant bit high, and so that's in the working register. And then I'm going to compare the input pins on port C, and it'll skip if it's equal to the working register. What value is in the working register? Well, I just put this value in the working register. Through the coding format of this instruction, it's just implied that you're comparing, the CP is comparing with the working register, but that doesn't actually appear in the mnemonic. So that's something that's good to remember. That's a note to myself. And if the push button is pressed and port C is equal with the WREG, it'll skip the next instruction, which is goTo, and the goTo sends it to another subroutine called loop, and this again is like a blink subroutine, but it's not. Instead I'm doing something different. I'm sending this value into port D, which is an output port, and then I'm complementing it, and I'm using this delay routine to complement that. I had to add in here into this loop bit test file skip if clear port C RC0, so we have to constantly check that I'm not pushing push button RC0. So I wrote in a comment that says that check if port C RC0 is clear. If I release the push button, then it'll skip, if it's clear, it'll skip this next line, which keeps everything in the loop, so it'll skip this, and then it'll go to main if I've taken my finger off the push button. And where's main? It goes back up here. And it's comparing if RC0 is equal to what's in the working register, and it'll keep branching until they are equal. When they are equal, it'll go to the loop again. So if in effect, what's going to happen when I get to my breadboard setup is if I push RC0, if I push the push button into the RC0 input, it will begin complementing port D, and if I release my finger off the push button, it'll cease complementing port D. Once again, when I push RC0 with the push button, it breaks out of this loop and goes into this complement subroutine. So in the resting state, it just cycles in here, these two code instructions, until the RC0 push button is pressed, in which case it skips this line and goes into this loop, complements port D, all the while checking RC0 to see if it's clear. If it is clear, it'll break out of this whole loop here. It'll skip this next goTo loop instruction, and it'll go back to main. It will get hung up in here just waiting and checking to see if RC0 is equal to the working register. So maybe I made this too complicated, but once again, compare file, skip if equal, but more specifically, compare the working register to a file and skip if they're both equal. And in this case, I'm comparing port C to the working register having this binary value of all zeros and a 1. Okay, one more thing before I go to my breadboard setup. And that is, I just added this to my code. When it initializes everything, I just cleared port D being the output port. Otherwise, the LEDs stay high, lit, and I wanted to have them clear upon pressing the mClear button. So this was helpful, so I put that in here.
All right. So here is port D. All these blue jumper wires, all connected to LEDs with 10K resistors on the other end. Of course, port D is an output port because I set it up that way. Port C, which is mostly green, which appears over here and here, is all input because I configured it that way. RC0 is over here, this line here. Okay, and RC0 is connected to a push button which has a pull down to ground, and when I push the button it receives a high, and this little board is powered by the power source on the experimenter's platform board for the chip. So here I will press it, and I will release my finger. It stops operating. It's in that first main subroutine that I created. If I push the push button again, it will resume complementing output port D. I just updated my code with a clear F port D instruction on the initialization so I can clear the LEDs. Otherwise, if I didn't add that line of code, I wouldn't be able to clear the LEDs on port D. Well, this opens up more possibilities for more experimentation. I could compare two different input ports. What else could I do with this? I could compare two different input ports with each other, or I could compare input ports individually to the working register, and maybe the different input ports would trigger go-to instructions that go to varying different subroutines that might be comparable to this complement subroutine, but maybe I could just get a port B input using the CPFSEQ instruction and make it sound a buzzer or something, just do something different. Well, there's lots of options. Thanks for watching.